Greetings, this is Artie from Artifact Electronics. In this episode, we'll be looking at this musical artifact. This is an EML 101 semi-modular synthesizer. This is my own personal instrument, which I acquired a few years ago. And this came out in the same era that the Minimoog and the ARP 2600 came out, which were both hugely successful instruments. The Moog being more successful than the ARP. And I guess what Electrocomp or Electronic Music Labs decided at that point was not to directly compete with the 500-pound gorillas, but rather go after the educational market. ARP also went after the educational market, but not exclusively, whereas EML did go after the educational market exclusively. This particular model is the EML 101. EML built a few other models, but the EML 101 was by far their most successful instrument. It was built from 1971 through 1981, and there are different estimates of how many of these were built, but generally I think it's agreed that the number lies between 1,000 and 1,500 in the 10 years that it was produced. Now, this is considered to be a semi-modular synthesizer, and what that means is, in stock form as it comes, it has internal connections for you to create all sorts of sounds, and which are lightly referred to by the block diagrams here. Little boxes which point at the next box. For instance, the oscillator point at the mixer box, and then the output of the mixer box points to the filter. But you may notice a bunch of quarter-inch jacks on the top row, and with those you could custom connect things. If for instance, one oddity on this is that oscillator 1 is used to modulate other oscillators, and there's no way in a standard form to hear what oscillator 1 sounds like. But if you want to do so, you can go to oscillator 1 to the output, and note that the up arrows on the patch points indicate outputs, and the down arrows indicate inputs. So if we patched into the oscillator 1 output and ran that into the filter mixer, external input, then we could hear it directly, but the difference of course being that out of the box you couldn't do that, but the patch points were provided so you could customize the signal path of the sound to create more unique sounds than you could without patch cords. Now, before listening to it and going through its features, we probably should have a look at the inside, because when I bought this, of course, I was assured that it was in perfect working condition and no work required and all of that good stuff, which wasn't true. There were a few problems with it. So if we have a look under the hood, I will tell you what I did to bring it back to full working condition, and we'll talk a little bit about what makes it tick. But before we look inside, let's have a look at some of the engravings that are on the instrument panel. I guess this was their way of inventorying this and making sure that nobody wandered off with it. Anyway, somebody with a rather unsteady hand engraved this, and what it says, it's probably difficult to see, so I'll read everything back to you. It says Music Ed, Music Therapy, University of Kansas. And over here is the serial number, which matches what the inside of it says, and it's number 1143. So this obviously started its life as an educational instrument at the University of Kansas, which is probably a fortunate thing for me, because if you look at the overall shape of it, the keyboard is nice and straight. There are no major dings on the cabinet, and the panel is also clean. You can't see some live performer having gotten excited and scratched the front panel while turning buttons and all of that. So it's actually a really nice example. And but that's for the history. I guess purists may say this should be buffed out or filled in and repainted, but I think it's an integral part of the instrument that that is a true hint to its history. Everything in the instrument is mounted to the front panel, so all you got to do is remove 5 screws. You got to remove the right screws because otherwise things start falling inside. But you take out the 5 correct screws and then lift the whole panel out, and there you go. There she is in all her beauty. And we start off with a power supply on this side and then move over with 3 main boards. Lots of pots mounted underneath. Everything is, the pots are either they're half hardwired and half well, whatever you call these single plug wired. And one thing that I'll say right off the bat that I think is very dangerous in here is you're looking at the main output part of the power supply. The black wires are ground, blue is plus 15 and red is minus 15. Now let's take an example of where they plug into the boards right over here. You may notice that there is no indication whatsoever of what the plug-in points are, what voltage they want. And of course I didn't pay attention, I didn't mark it, and I started ripping out things, and then I realized that, uh-oh, what goes where? Now fortunately there are op amps in here, and which we'll get to later, but there's a bunch of 741s in here, metal cans, single op amp. But I know from the schematics I knew that those were running off plus minus 15, so it was actually not that hard for me to identify what the power rails, or where the power rails should go. And I used tape, I used painter's tape to mark everything, and then of course I ripped all the tape off, not noticing that I should have marked the board. But I guess next time before tearing anything apart in here, I will take a black marker and mark all of the power connections, so I won't blow up this board by plugging in power wrong. There's another one, and there's another one. So might as well get started with the power supply. So here's the power supply. These wire nuts down here poking through are my doing, because the AC lines are all hardwired, and I had to go through several revisions, removing the board, fixing something, putting it back, and I got sick and tired of having to solder the AC lines, so wire nuts it shall be. Another thing I noticed was that the board smells a lot like old electronics. And actually it smells pretty similar to one of the tube testers I serviced a few episodes back. And I kind of did some empirical investigation, and the similar smells are coming from the transformer, both in here and in the tube tester, and it's probably emitting all sorts of noxious fumes when it's on. But it kind of smells good, so but anyway, what was wrong with this and why did I tear it apart? It's hard to describe, but the instrument, it sounded like shit. I mean, the sound coming out of it, the oscillators, just nothing sounded right. And I put the power rails on the scope, and there was significant ripple and other garbage riding on the power lines. So of course, no big mystery. I replaced the caps, all of the caps in here, and I checked the diodes, and everything seemed okay. And I turned the instrument on, and it still sounded like shit. I mean, not as shitty as it sounded before, but it still was pretty bad. So it's a simple linear power supply. There wasn't really much else to do, but underneath these barrier strips here is where the voltage regulators are mounted. Nothing, no pass transistors, nothing like that. There's a 7815 and a 7915 mounted underneath here with a heatsink, and is heat-sunk actually to the front panel, which is probably nice if you're on those cold winter nights, because this side of the panel does provide or turn out to be a nice hand warmer. But there really wasn't much else in there, and I popped the regulators out, which were date coded about 72 or 73, and just put new ones in, and lo and behold, it no longer sounded like shit. So I looked at the power rails on the scope again. They were relatively clean now, and that was the whole problem. Well, the whole problem was that I pretty much replaced a lot of stuff in the power supply. But the old saying still holds. The first thing you should always check is the power supply, even if the lights come on. And so this would have been a perfect example, on eBay saying, hey, power's up, make sound, but nobody would add, sounds like shit. I didn't buy it on eBay. I bought it privately through someone I knew and had bought other stuff from. But there was no mention made of the instrument sounding like shit. But so once that was fixed, then I had to look into another problem, and that was that oscillator 4 was not tracking the keyboard. So when you hit a key on the keyboard, it would sound, but it always sounded at its lowest pitch. And to diagnose that, or how I diagnosed that, let's have a look at the next board in line. All right, I was wrong when I described the next problem. I did have the problem where the oscillator didn't track the keyboard, but that was user error, because I just had set the pitch source to some wrong setting and it was ignoring the keyboard. What the real problem was that I couldn't dynamically control the filters. I could make the filters, I could change the frequencies on the filter by turning the front panel knobs, but they would not respond to the modulation, to the envelope generators or anything like that. And so I did check schematics, and as I said before, there's an army of 741s and sprinkled with some 748s on here. They're all metal can. It's not a problem to replace them because the board outline actually assumes a dual inline package. So you could socket these and put, regular dip chips in here if you had to replace them. And I hear the purists yelling again, don't ever replace a metal can package with a dip package, and so on and so forth. It depends. If any of the regular op amps ever go, it depends on how much it's going to cost me to get a replacement, or if I can even get a replacement. But the good part is I'm not at the end, because if all else fails, I can always put regular 741s in there. But to diagnose the problem, basically these instruments accept, or the keyboard generates a linear control voltage for the pitch. And on this particular instrument, it's 1.2 volts per octave, which kind of makes sense on paper, considering there's 12 notes in an octave, so, every 100 millivolts jumps a semitone, which is completely incompatible with what Moog did at the time and what modern modular synths do, which are linear 1 volt per octave, but that's a different issue. So all these control voltages come in from the keyboard modulations for vibrato or tremolo or whatever envelopes for the filter. They're all summed, but just like with pitch, the voltage required by the filters and the oscillators and everything else needs to be of a logarithmic nature. No, I'm sorry, of an exponential nature, whereas the incoming voltage is linear. So what most of these instruments have is they sum up all of the control voltages, and just before they get sent to their destination, they run through a linear to exponential converter. And linear to exponentials have to be pretty accurate, especially when it comes to pitch control, because you will hear it if there's bad circuit design or flaky components in that circuit. So what was used to affect the conversion was a Fairchild MU-A726 temperature control differential pair of transistors. And here's what it looks like. There's basically two transistors in this package, and there's also temperature control circuitry on there that keeps the metal can package at as constant a temperature as it can, so that the performance of the transistors in there doesn't fluctuate, and those transistors are used for the expo converters. Now, there's some problems with this part. First of all, this part hasn't been made in many years. And I mean, we're talking 20 plus years, if not more. So what that means is they're hard to find, and when you do find them, they are rather expensive. When I was looking for them, the average price for them was $100. $100 for a metal can package with two transistors in it. I don't care how old or how accurate it is. It's a bitter pill to swallow, but after checking around and seeing what else I could do, how I could finagle it, there was no way to do it. So I had to go and find an original replacement part. Now, with replacement parts that are difficult to find and that are rare, a lot of them are sold. Not that many are sold in the US or the Western world, but a lot of them seem to exist offshore, where people advertise them, and not only advertise them in quantity, but for prices like $20 or $30. Well, the $20 or $30 ones, and even the $70 and $80 ones, you have a high chance of getting a fake. Basically, where they take a metal can package and reprint them to make them look like one of these things. And I read several horror stories about people having spent, say, $50 a pop and bought a half dozen, and they never really found out what was in there, but it wasn't a MU-A726. So anyway, that made it a little bit easier for me to swallow the pill of having to pay $100 for one of these. But you know, where to buy it from? There were none on eBay locally. There were like 6 or 7 from China, but none locally. But finally I found somebody that I had done business with before with musical instrument parts, and he had 2 or 3 of them, and he didn't really want to sell them. He said, I need them for myself. But after a lot of arm twisting and begging and pleading, he finally sold me one for $100. And that solved the problem of the filter control, because I tested. Here is the part in question that's sticking out a little higher than the others. Here's one of them, and here's the other one. And that one, I basically checked voltages, and there was a linear voltage. The control voltages were going in here, but there was nothing coming out at the other end. It was basically stuck at ground. So it was a simple matter of replacing it. But when I finally got the part, it was a little bit scary to have to put the part in and start soldering it. I didn't want to solder it, so I'm actually measuring tip temperature and stuff like that to make sure that I'm not going to kill the part during the soldering process. But it all ended well. I put it in, and the filter started to work. And that was basically all that was wrong with this. So let's have a quick look at the remaining 2 boards, and then put it together again. Here we have boards number 2 and 3, wired in the same neat fashion as the other board you saw. Actually, I have cleaned it up a bit. Every single zip tie you see in here was added by me. There were no zip ties in here. And it looked accordingly. Not that it looks a whole lot better now, but they didn't pay a lot of attention to wiring. After all that effort to create constant control voltages for everything, the actual control voltage is run from board to board in plain unshielded wire. So I don't know what they were thinking. I guess it's an analog synthesizer, who cares, but a little bit of shielded wire could have probably made things a little bit cleaner. But then again, the absence of the cleanliness in sound is probably what gives analog synthesizers their specific character. So maybe that's why they left this mess in there. Anyway, board number 2 is where the actual oscillators are located after receiving control voltages and gates from board number 1. And then we have board number 3. Board number 3 actually contains the filter and the VCAs and some preamp stuff, and that's all she wrote. If we look at board 3, we can see that there is one spot where they did use shielded wire, and that is the actual output stage over here, which takes the final signal, and utilizing the shielded wire, runs the output to the master volume pot. And looking at this really closely, that is the only piece of shielded wire utilized in the entire instrument. And that's about it. That's as far as the teardown and the repair description goes. Oh, one other thing I had to do is there were a few scratchy pots in here. Some of them were really scratchy, and they are sealed pots. So the problem with sealed pots is that if they become real scratchy, you have to replace them. I did find the replacements locally in some dusty back room of a electronic surplus dealer, and they weren't cheap, but I did find exact replacement for them. Another point of interest here is note that this particular one here is a 4-terminal pot, so it has the regular power top and bottom of resistor and tap coming out, but then it's got a 4th terminal coming out, which is basically a permanent center tap. So that's connected to the center of the resistor that's inside, and they use this kind of a pot to basically alter waveforms and stuff like that, using a pot rather than having a switch where they say we want a square wave or we want a sine wave. You can turn a pot to basically go from square to sine wave in infinite steps. And those kinds of pots there are numerous ones of them used on this board. Another thing that spells trouble is some signals are grounded with a tab against the front panel. And this is the front panel. These things can corrode very easily. I removed all of them and cleaned them up. And some did show traces of corrosion. And it turns out that this is the ground connection for some of the pots. For instance, the center connection on these pots over here is connected to the system ground. And if this is dirty, these inputs float, and you will get some really interesting sounds coming out of this thing. But that's about it. Let's put the panel back and do a quick functional run through. Okay, the panel's back in, and I kind of dialed in a sound here. So Let's see if she works. So this is a very basic patch using 3 oscillators that are slightly detuned to fatten up the sound. One other thing to test is to see if all the keys work, because they have usually open contacts in the keyboard and they tend to corrode and either double trigger or don't trigger reliably or don't trigger at all. So one thing to do is play every note and see if it sounds. So all the keys seem to be okay. Another thing to try is the glide function. Under normal circumstances, whenever you play a new key, the pitch jumps to the key you pressed instantaneously. But what you can do on a synthesizer is essentially insert an RC circuit between the control voltage and the oscillators, and the RC circuit will basically take a while for the capacitor to charge. So let's turn up the glide a little bit. If we are here, turn it about halfway, and then press an upper C, and we can change how long the whole thing takes. That works. A little bit of modulation maybe. We can modulate the frequency of all 3 oscillators, and that is the vibrato effect. Oscillator 1 is set to operate in the low frequency range and to a triangle wave, so the pitch is affected in a triangular fashion. We can change this. We can go to a oscillator 1 goes to a square wave, an asymmetric square wave that has a low duty, actually a high duty cycle, and a sawtooth, and an inverted sawtooth. And the fun goes on and on. That should probably be left for another episode to go through this. The only other thing, let's see, what's remaining here? Of course, there's the filter itself. It is now set to low pass mode. You can change the filter mode, and again in infinite steps because there's no switches, but remember the 4 terminal pots, they'll let you go seamlessly from low pass to band pass all the way up to high pass. And anywhere in between. And that concludes a quick run-through of the instrument. And as you can see, it's working fine with the things we fixed previously. One thing I need to warn you of is when I was playing with this, it seems that the scaling of the control voltage is slightly off, and when you get to the upper registers, the instrument seems to start sounding a little bit flat. But the service manual does include a procedure for how to properly tune that, and that's probably the next thing I'll need to do, along with the handle. I mean, most of the handle is still here, but the actual strap is gone, so it's going to need a new handle too. But other than that, all in all, I think it's a great instrument, And I hope you enjoyed watching and hearing it. So make sure to mash that thumbs up button and to also subscribe. And hopefully we'll see you next time.